Autumn 1938, Japan, a design hall near Nagoya. Blueprints lie flat across a long wooden table. American measurements, American tolerances, American ideas translated carefully into Japanese annotations. Engineers stand quietly, hands clasped behind their backs, studying a foreign aircraft design that has already been dismissed by its creators. Outside, test engines echo across the airfield. Inside, the mood is calm, confident. To Japan's aviation planners, this rejection does not signal failure, it signals opportunity. The United States, they believe, has been too cautious, too conservative, too unwilling to see the potential hidden inside the airframe. What America discarded, Japan will refine. There is logic in this confidence. Japan has adapted foreign technology before. Naval guns, engines, industrial methods. Each time, improvement followed imitation. Each time, pride was justified. The aircraft on the table appears sound, large, ambitious, capable of range and payload beyond most Japanese designs. On paper, it promises reach, exactly what an island empire believes it needs. No one in the room speaks of why America walked away. No one asks whether rejection might be intentional. The decision feels efficient, rational, safe. And in that quiet certainty, the most dangerous assumption of Japan's wartime aviation effort takes shape, one that will not reveal itself until engines fail, crews struggle, and combat leaves no room for theory. By the late 1930s, Japan's aviation ambitions were expanding faster than its industrial foundations. The nation had proven it could design agile, lightweight aircraft optimized for range and maneuverability. What it had not yet proven was the ability to sustain heavy, complex aviation programs at scale, especially those involving large airframes, long-range bombing, and sustained mechanical reliability. Japan's strategic geography shaped everything. An island nation with expanding continental commitments, it required aircraft that could travel far, carry meaningful payloads, and return reliably. The lessons of China and the growing possibility of conflict with Western powers pushed planners toward long-range solutions that domestic design philosophy had not fully mastered. So Japan looked outward. This was not unusual. Japanese industry had long studied Western engineering. Naval architecture, metallurgy, optics, and aviation had all benefited from careful observation of foreign designs. In aviation especially, American manufacturers were watched closely. The United States possessed deep industrial capacity, advanced testing infrastructure, and a willingness to discard designs that failed to meet demanding standards. To Japanese planners, this last trait appeared inefficient rather than wise. American aviation culture, they believed, was constrained by bureaucracy and excess caution. Projects were canceled not because they were fundamentally flawed, but because they failed to align with narrowly defined requirements or immediate operational doctrine. To an empire seeking rapid expansion, those rejected designs looked like opportunities. There was also urgency. Japan's aircraft industry was productive but strained. Materials were limited, engines were pushed to their limits. Large airframes placed stress not only on factories, but on supply chains that were already vulnerable. Developing an entirely new heavy aircraft from first principles required time Japan did not believe it had. Foreign designs offered shortcuts. An American aircraft rejected by U.S. authorities or industry came with something invaluable, proof that it had already been tested extensively. Wind tunnel data, structural calculations, flight trials. Failures identified and documented. To Japanese engineers, this represented a foundation on which improvements could be layered. The logic seemed sound. If American aviation sector, led by companies such as Douglas Aircraft Company and Boeing, discarded a design because it did not suit American doctrine, that did not mean it could not suit Japan's needs. Different missions required different compromises. Japanese planners believed they understood those compromises. They envisioned aircraft that would fly farther than American bombers, operate with fewer resources, and strike targets across vast distances. Where American doctrine emphasized mass production and standardized logistics, Japan believed precision, discipline, and adaptation could compensate for industrial disparity. This belief had precedent. Earlier in the decade, Japanese engineers had successfully adapted foreign engines and aircraft concepts, often reducing weight and refining aerodynamics to suit their operational style. These successes reinforced confidence that adaptation, not originality, was the most efficient path forward. But confidence, once reinforced, can become blind.
The international aviation environment of the late 1930s was unforgiving. Aircraft were growing larger, heavier, and more complex at a pace that strained even the most advanced industries. Structural margins shrank, engine tolerances tightened, minor miscalculations could cascade into systemic failure. American aviation responded to this complexity with aggressive testing and conservative acceptance criteria. Designs that showed promise but lacked reliability were abandoned early, often quietly. Japanese observers did not always see those quiet rejections as warnings. They saw them as unfinished work. Within Japan, institutions like Imperial Japanese Army Air Service and Imperial Japanese Naval Air Service competed for resources and influence. Both branches sought aircraft that could justify expanded budgets and strategic reach. Large, ambitious designs carried political weight. An American-derived aircraft promised more than performance. It promised legitimacy. Possessing a heavy aircraft inspired by Western engineering signaled that Japan could stand alongside industrial powers, not merely confront them asymmetrically. It suggested parity, technological, strategic, and symbolic. Engineers at firms like Mitsubishi and Nakajima understood the risks, but they also understood the expectations placed upon them. Leadership wanted results. The timeline was shrinking. The war horizon was expanding. In that pressure, skepticism became costly. Questions about why America rejected certain designs were asked, but not always pursued to their uncomfortable conclusions. American industrial context was different. Their testing budgets were larger. Their margin for delay was greater. Their doctrine allowed them to walk away from projects Japan felt compelled to salvage. This difference in perspective mattered. American rejection was often not about immediate failure, but about long-term sustainability. An aircraft that performed well briefly but degraded under extended operational stress was unacceptable. Japan, facing different constraints, sometimes accepted those risks knowingly, believing operational necessity justified them. What Japanese planners underestimated was how those risks compounded. Weight reductions introduced vibration, extended range strained engines, structural compromises multiplied across reduction batches. Each individual decision appeared manageable. Together, they created fragility. But at this stage, fragility remained invisible. On paper, the aircraft looked promising. On the drafting table, it appeared adaptable. In planning rooms, it represented progress. No one yet heard the warning signs that only flight hours could reveal. No one yet understood that America's rejection was not hesitation, but diagnosis. That realization would come later, when improvement was no longer possible and replacement was no longer affordable. And when it did, it would expose the difference between adapting a design and understanding the system that produced it. In the United States, aircraft rejection in the late 1930s was rarely dramatic. There were no public failures, no press conferences. Most projects simply ended quietly, filed away after test reports concluded that promise did not outweigh risk. To Japanese observers, the silence was misleading. American aviation doctrine at the time was shaped by abundance. Large budgets allowed extensive prototyping. Multiple competitors could pursue similar concepts simultaneously. If one design revealed structural weakness, maintenance complexity, or performance instability, it could be abandoned without consequence. Rejection was not a judgment of imagination. It was a judgment of endurance. American test programs focused relentlessly on repeatability. Could an aircraft perform not just once, but thousands of times? Could it be flown by average crews, maintained by ordinary ground personnel, and survive the friction of mass service? If the answer was uncertain, the design was set aside, no matter how impressive it looked in isolated trials. The aircraft Japan would later pursue had failed that test. On paper, it promised capability. Size, payload, range. But in American evaluation, those advantages came at a cost that was difficult to justify. Structural weight margins were thin. Power plant demands exceeded what engines of the era could reliably sustain. Cooling, vibration, and fatigue issues appeared under extended testing. None of these flaws were dramatic on their own. Together, they formed a pattern. American engineers recognized as improving one weakness amplified another. Reinforcing structure increased weight. Weight reduced range. Increased power strained engines. Strained engines reduced reliability. Each correction produced a new compromise, pushing the aircraft further from operational practicality. The United States could afford to walk away from that spiral. Japan could not. What Japanese planners saw as American caution was in reality American selectivity. The design was not rejected because it failed to fly. It was rejected because it could not be trusted to fly consistently, safely, and economically across the lifespan demanded by modern war. This distinction mattered. Japanese engineers inherited drawings, test data, and concepts, but not the institutional memory that accompanied them. They did not experience the cumulative frustration of incremental fixes that failed to resolve fundamental limitations. They saw the design closer to its idealized form, stripped of the doubts that had already ended its American path. And in that gap between data and experience, misinterpretation took root. Japanese adaptation efforts focused on refinement, weight reduction, aerodynamic smoothing, material substitutions. Each modification aimed to align the aircraft with Japanese doctrine: long range, disciplined cruise, precise execution. But refinement cannot correct foundational imbalance. The original American rejection had identified systemic fragility, not superficial flaws. The airframe demanded more power than engines could sustainably provide. The structure required tolerances difficult to maintain under wartime pressure. Maintenance intervals were narrow, leaving little room for error. American industry recognized that such an aircraft would consume resources disproportionate to its return. Japanese leadership, operating under urgency, reached a different conclusion. They believed that disciplined operation could compensate for mechanical sensitivity, that elite crews could overcome reliability limits, that careful handling could preserve engines and structures beyond what testing suggested. This belief reflected a broader cultural assumption within Japanese military planning, that skill and spirit could offset material disadvantage. In aviation, this assumption was dangerous. Aircraft do not respond to determination, they respond to physics. As development continued in Japan, warning signs began to surface. Manufacturing variability introduced inconsistencies the original design could not tolerate.
Angle 1. The human angle. Engineers asked to believe. Inside Japan's aircraft factories, belief became a requirement. Designers and engineers were not ignorant of the aircraft's sensitivity. They saw the maintenance reports. They tracked engine hours. They read pilot feedback written in careful, restrained language that hinted at deeper concern. But belief, shared belief, was essential for momentum. Doubt slowed production. Doubt invited scrutiny. Doubt threatened schedules already under strain. Many of the engineers involved were young, trained quickly, thrust into responsibility by an expanding war economy that valued output over deliberation. They were asked to refine a foreign design while simultaneously adapting it to materials that were less consistent and engines that were already operating near their limits. This was not negligence, it was pressure. Each modification felt justified in isolation. Reduce weight here, reinforce there, accept narrower tolerances. The aircraft could fly. It did fly, and early demonstrations, conducted under controlled conditions, appeared to validate the effort. Human psychology filled the gaps that data could not. When problems appeared, they were interpreted as transitional. Wartime shortages explained delays. Training would solve handling issues. Discipline would preserve engines. Spirit would overcome fragility. No one wanted to be the voice that said the aircraft itself might be wrong. Because that voice would not only challenge a design, it would challenge the decision to proceed at all. And by this point, that decision was inseparable from reputation. Angle 2, the technological angle, when margins vanish. From a purely technical perspective, the aircraft's greatest weakness was not any single failure point. It was margin, or the lack of it. Every complex machine relies on margin, extra strength, extra cooling, extra tolerance, space for error. In American testing, this aircraft had revealed how quickly those margins disappeared under sustained use. Japan inherited a design that already lived close to its limits. Efforts to adapt it only narrowed those limits further. Weight reduction improved range but increased structural stress. Engine tuning delivered power but shortened lifespan. Aerodynamic refinement reduced drag but magnified vibration. Each improvement made the aircraft more capable on paper and more delicate in reality. In peacetime testing, such fragility might have been manageable. In wartime production, it was lethal. Factories worked long hours. Quality varied between batches. Materials fluctuated. Skilled labor was stretched thin. Under these conditions, designs with narrow margins suffer first. The aircraft systems were unforgiving. Small deviations produced cascading effects. Cooling issues led to engine wear. Engine wear produced vibration. Vibration accelerated structural fatigue. Fatigue shortened operational life. These relationships were understood academically, but their speed was not. By the time patterns became undeniable, aircraft were already deployed. Angle 3, the leadership angle, momentum over doubt. Leadership faced a dilemma. Acknowledging the aircraft's limitations would not merely halt production, it would expose a strategic gamble that had already consumed resources, prestige, and time. In a military culture that valued decisiveness, reversal carried heavy cost. So momentum became policy. Problems were addressed tactically rather than strategically. Maintenance procedures were revised, training manuals expanded, operational limits adjusted. Each change treated symptoms without confronting cause. Leadership framed the aircraft as demanding, not flawed. This framing mattered. Demanding aircraft require better pilots, better discipline, greater commitment. Flawed aircraft require replacement. The distinction allowed the program to continue without loss of face. But demanding machines extract payment eventually. Pilots flying the aircraft began to report fatigue, mechanical and personal. Missions required constant attention. Minor tours produced immediate consequences. Ground crews worked longer to keep aircraft operational for fewer hours. These were not signs of excellence. They were signs of imbalance. Still, the aircraft remained in service. Because at this stage, belief, investment, and necessity had fused. The design was no longer just a machine. It was a statement that Japan could take what America rejected and prove it wrong.
That statement would soon be tested not in factories or planning rooms, but under operational pressure where belief carries no weight, and where compromise reveals its cost. Angle 4, the comparative angle, what America avoided. From the outside, it appeared that Japan and the United States were pursuing similar goals: range, payload, reach. In reality, they were solving different problems with different tolerances for risk. American aviation doctrine in the late 1930s assumed long wars fought by large organizations. Aircraft would be flown by thousands of crews, not a select few. Maintenance would be conducted in improvised conditions. Failures would occur at scale. Designs that could not absorb this friction were liabilities, no matter how promising they looked in isolation. This is what America saw and rejected. The aircraft Japan adopted demanded precision. It demanded consistency. It demanded careful handling, constant monitoring, and ideal conditions. These demands were not flaws in themselves. They simply did not align with American assumptions about how war actually unfolded. American planners favored designs that tolerated misuse, that flew acceptably even when engines were tired, crews were average, and parts were imperfect. This philosophy sacrificed theoretical peak performance for operational resilience. Japan's approach inverted that logic. By adopting a design already operating close to its limits, Japanese planners implicitly assumed that wartime conditions could be controlled, that crews could compensate for fragility for discipline and skill. This assumption held briefly, then collapsed. The comparison was stark. Where American aircraft degraded gradually, the adapted design degraded suddenly. Where American systems absorbed error, this one magnified it. The difference was malnational capability. It was philosophical choice. And philosophy, once embedded in metal, cannot be revised easily. Angle 5, the industrial angle, when production became the enemy. As the war expanded, Japan's industrial environment changed rapidly, and not in ways the aircraft could tolerate. Raw materials became inconsistent, skilled labor was diverted, subcontractors varied in quality, production lines stretched beyond their design capacity. In this environment, aircraft with generous margins survived, aircraft with narrow tolerances did not. The adapted design suffered immediately. Aircraft emerging from different factories behaved differently. Engines of nominally identical specification produced uneven performance. Components that required precise alignment drifted out of tolerance under production pressure. Maintenance crews responded heroically. They improvised, they adjusted, they cannibalized aircraft to keep others flying. But every workaround reduced operational lifespan. Every compromise shortened the window of usefulness. The aircraft demanded an industrial ecosystem Japan could no longer provide. This was not a sudden collapse, it was erosion. Availability rates fell, sortie generation slowed, pilots flew fewer hours in aircraft that required more care. Operational commanders began to plan around the aircraft's limitations rather than its strengths. This inversion marked the moment when an asset becomes a burden. American rejection had anticipated this. Japan's adaptation could not escape it. Angle 6, the moral angle, pride and the cost of commitment. By the time these realities became clear, the aircraft was no longer just a program, it was a symbol. It represented faith in adaptation, confidence in engineering, proof that Japan could take what America rejected and prove it wrong. To abandon it would mean admitting that America's judgment had been correct all along. That admission was unthinkable. So the aircraft remained in service longer than logic justified. Losses were rationalized, failures attributed to misuse, replacement plans delayed. Pride transformed caution into stubbornness. This was not unique to Japan. All wartime nations struggle with sunk cost, but in this case, the cost was compounded by the narrative attached to the aircraft, that it was a reclaimed opportunity, not a compromised inheritance. Pilots sensed this contradiction. They flew an aircraft that demanded perfection from crews operating under increased strain. They were asked to deliver results while compensating for mechanical fragility. Each mission carried not just operational risk but symbolic weight. Failures were personal. When aircraft failed, it felt like betrayal, of training, of effort, of belief. This emotional burden mattered. Fatigue was not just physical, it was psychological. And psychology, in war, is decisive. Angle 7, the enemy angle, how opponents recognize the weakness. Allies encountering the aircraft in combat noticed something quickly. It was capable, sometimes impressively so. When flown within narrow parameters, it performed well, but it lacked consistency. Engagements varied, performance fluctuated, patterns emerged. This inconsistency was its signature. Opposing pilots learned to wait, to extend engagements, to apply pressure. The aircraft's strengths faded over time within a sortie, its weaknesses grew. What had once looked formidable became predictable. This was the final irony. Japan had believed it was exploiting an American oversight. Instead, it had inherited a problem the United States had already solved by walking away. The enemy did not need to out-innovate the aircraft, they only needed to survive it. And as the war ground on, survival favored systems with endurance, not brilliance. By this stage, the outcome was no longer in doubt. The aircraft would not redeem its promise, it would not justify the gamble placed upon it. It would serve, suffer, and gradually recede, leaving behind lessons written in fatigue reports, maintenance logs, and quiet reassessments. The greatest mistake was no longer theoretical, it was operational. And soon it would be measured not in assumptions but in losses, when the aircraft faced sustained combat conditions that allowed no room for belief.
The transition from expectation to consequence did not happen in a single moment. It unfolded gradually, then all at once. At first, the aircraft entered service under controlled conditions. Missions were planned carefully, crews were selected deliberately, maintenance schedules were tightened. For a brief period, results appeared to justify the decision. The aircraft flew. It reached targets that others could not. It carried payloads that reinforced confidence at headquarters. But war does not remain controlled. As operational tempo increased, the aircraft was asked to do what it had been designed to do, repeatedly. Long flights, high loads, minimal downtime, exposure to weather, vibration, and fatigue that no test program could fully simulate. This is where the design's hidden costs emerged. Engines began to show accelerated wear. Oil consumption increased. Cooling margins narrowed. Structural stress accumulated in ways that were difficult to detect until failure occurred. Maintenance crews responded by shortening inspection intervals, but this reduced availability. Aircraft spent more time grounded, waiting for parts that were increasingly scarce. Commanders faced an impossible trade-off: fly fewer sorties and preserve the aircraft, or fly more and accept degradation. In a war where reach and pressure mattered, preservation was rarely chosen. Pilots felt the shift first. Takeoffs required greater care. Power settings were adjusted cautiously. Instruments demanded constant attention. Minor anomalies, previously dismissed, now signaled potential mission aborts. Confidence eroded not through catastrophe, but through accumulation. The aircraft no longer felt forgiving. Combat exposure magnified every limitation. Maneuvers that had once been routine now carried risk. Sustained power settings punished engines. Structural vibrations intensified under evasive action. When damage occurred, recovery margins were slim. Losses followed. Not dramatic losses that could be explained away as bad luck, but persistent, uneven attrition that disrupted unit cohesion. One aircraft would complete missions reliably. Another, outwardly identical, would fail after hours in the air. Predictability vanished. This unpredictability was the turning point. An aircraft that cannot be trusted uniformly cannot anchor strategy. Planning becomes reactive. Confidence dissolves. Crews adjust behavior not to achieve objectives, but to avoid failure. American evaluators had anticipated this exact pattern years earlier. It was why the design had been rejected quietly and without regret. Japan now confronted the same conclusions, but under wartime pressure, with no alternative ready. Leadership attempted mitigation. Operational limits were revised, payloads reduced, power restrictions imposed. Training emphasized conservation rather than performance. These changes improved survivability marginally, but they also undermined the aircraft's original purpose. The range advantage shrank, the payload advantage disappeared. What remained was a complex machine demanding careful handling in a war that rewarded robustness. By this stage, the aircraft's reputation had shifted. It was no longer seen as an opportunity. It was seen as a liability that could not be abandoned. Pilots flew it because they had to. Ground crews maintained it because replacement was impossible. Commanders deployed it because plans depended on its existence, even as they quietly adjusted expectations downward. This was the true climax, not a single battle, but a systemic collapse of confidence. The realization spread unevenly but decisively. America had not misjudged the aircraft. It had understood it too well. Japan's greatest aviation mistake was no longer abstract. It was visible in sortie reports, maintenance backlogs, and operational compromises that rippled outward across the air war. And as pressure mounted, one final phase remained, when the aircraft's weaknesses would no longer be manageable and consequences would arrive faster than adaptation. That phase would remove all remaining ambiguity. By the time the aircraft reached sustained combat employment, the balance had already shifted. What remained was confirmation. Operational commanders now faced a machine whose performance envelope had narrowed with every passing month. The aircraft could still fly long distances, but only under carefully constrained conditions. It could still carry payloads, but only at the cost of engine life. It could still be deployed, but only with a maintenance burden that drained surrounding units of time and parts. War compressed those choices. As Allied pressure increased, sortie rates rose. Airfields were attacked, supply chains fractured. Engines were run harder than recommended. Aircraft were repaired in the open, under threat, by crews who no longer had the luxury of ideal conditions. This is where the design finally broke free of theory. Failures accelerated. Engines seized mid-flight. Structural fatigue produced sudden, unrecoverable damage. Aircraft were lost not because they were outmatched in combat, but because they could not survive the cumulative stress of repeated operations. For pilots, the psychological toll became as heavy as the mechanical one. They entered missions aware that the aircraft might fail without warning, not from enemy fire, but from inner limits already exceeded. Confidence, essential in aviation, eroded. Crews compensated by flying conservatively, which reduced effectiveness and increased exposure time. Every mission demanded trade-offs that should not have existed. Allied forces began to recognize the pattern. They encountered an aircraft that appeared formidable on first contact, then diminished rapidly as engagements extended. Its initial reach was impressive, its staying power was not. Opponents adjusted tactics accordingly, stretching engagements, forcing sustained power settings, applying pressure rather than seeking decisive blows. The aircraft's greatest weakness was no longer hidden. It was time. The longer it was asked to perform, the more likely it was to fail. This realization spread through Japanese aviation units unevenly but decisively. Some commanders restricted use, others pressed on, believing necessity outweighed risk. The result was inconsistency. Aircraft employed differently across units, producing uneven results that further undermined confidence. By this stage, replacement was impossible. Resources had already been committed. Alternative designs were delayed or incomplete. The adapted aircraft remained in service not because it was effective, but because nothing else could fill the role. This is the point where mistakes become irreversible. The original American rejection had occurred early, before prestige, production, and strategy were entangled. Japan's commitment came too late to reverse. What began as adaptation ended as entrapment. Losses mounted quietly. Not catastrophic enough to force immediate abandonment, not minor enough to ignore. They accumulated in maintenance logs, pilot rosters, and operational planning adjustments that steadily reduced ambition.
By the final phases of the conflict, the aircraft no longer represented reach or advantage, it represented obligation. Units planned around its limitations, missions were redesigned to accommodate its fragility, strategy bent to protect the machine rather than exploit it. This inversion marked the true turning point. An aircraft exists to serve strategy. When strategy exists to serve an aircraft, the balance has already failed. Japan's greatest aviation mistake was not that the aircraft performed poorly in isolation, it was that it consumed effort, belief, and resources that could not be recovered, while delivering diminishing returns. In hindsight, the irony was unavoidable. America had rejected the aircraft not because it lacked potential, but because it demanded too much in return. Japan accepted it, believing discipline and adaptation could compensate. War proved otherwise. By the time this truth was fully understood, there was nothing left to change, only to endure. And in endurance, the cost became final, measured not in intention or ambition, but in aircraft lost, crews exhausted, the strategic options quietly removed from the table. What followed was not collapse, but resignation. The aircraft remained in service to the end, not as a symbol of innovation, but as a reminder of a decision made without fully understanding why someone else had already walked away. And with that realization said, the war moved into its closing chapters, carrying forward lessons that would only be acknowledged after silence replaced engines. By the final years of the war, the consequences of the decision had settled into the fabric of Japan's aviation effort. They were no longer debated, they were managed. The aircraft remained in service because removing it would have created a vacuum that could not be filled. Production lines, once opened, could not be easily repurposed. Training pipelines were already shaped around its systems. Maintenance doctrine had been rewritten to accommodate its weaknesses. Strategy, reluctantly, adapted itself to the machine. This adaptation came at a cost that grew heavier with time. Aircraft availability declined steadily. Units that once planned missions around capability now planned around scarcity. Operational commanders learned to ration sorties, not because targets were fewer, but aircrafts could not endure sustained use. Engines were run harder than recommended. Aircraft repaired and open under threat by crews who no longer had the luxury of ideal conditions. This is where the design finally broke free of theory. Failures accelerated. Engines seized mid-flight. Structural fatigue produced sudden, unrecoverable damage. Aircraft were lost not because they were outmatched in combat, but because they could not survive the cumulative stress of repeated operations. For pilots, the psychological toll became as heavy as the mechanical one. They entered missions aware that the aircraft might fail without warning, not from enemy fire, but from inner limits already exceeded. Confidence, essential in aviation, eroded. Crews compensated by flying conservatively, which reduced effectiveness and increased exposure time. Every mission demanded trade-offs that should not have existed. Allied forces began to recognize the pattern. They encountered an aircraft that proved formidable on first contact, then diminished rapidly as engagements extended. Its initial reach was impressive, its staying power was not. Opponents adjusted tactics accordingly, stretching engagements, forcing sustained power settings, applying pressure rather than seeking decisive blows. The aircraft's greatest weakness was no longer hidden. It was time. The longer it was asked to perform, the more likely it was to fail. This realization spread through Japanese aviation units unevenly but decisively. Some commanders restricted use, others pressed on, believing necessity outweighed risk. The result was inconsistency. Aircraft employed differently across units, producing uneven results that further undermined confidence. By this stage, replacement was impossible. Resources had already been committed, alternative designs were delayed or incomplete. The adapted aircraft remained in service not because it was effective, but because nothing else could fill the role. This is the point where mistakes become irreversible. The original American rejection had occurred early, before prestige, passion, and strategy were entangled. Japan's commitment came too late to reverse. What began as adaptation ended as entrapment. Losses mounted quietly, not catastrophic enough to force immediate abandonment, not minor enough to ignore. They accumulated in maintenance logs, pilot rosters, and operational planning adjustments that steadily reduced ambition. By the final phases of the conflict, the aircraft no longer represented reach or advantage, it represented obligation. Units planned around its limitations, missions were rewritten to accommodate its fragility, strategy bent to protect the machine rather than exploit it. This inversion marked the true turning point. An aircraft exists to serve strategy, and strategy exists to serve an aircraft. The balance has already failed. Japan's greatest aviation mistake was not that the aircraft performed poorly in isolation, it was that it consumed effort, belief, and resources that could not be recovered, while delivering diminishing returns. In hindsight, the irony was unavoidable. America had rejected the aircraft not because it lacked potential, but because it demanded too much in return. Japan accepted it, believing discipline and adaptation could compensate. War proved otherwise. By the time this truth was fully understood, there was nothing left to change, only to endure. And in endurance, it thus became final, measured not in intention or ambition, but in aircraft lost, crews exhausted, and strategic options quietly removed from the table. What followed was not collapse, but resignation. The aircraft remained in service to the end, not as a symbol of innovation, but as a reminder of a decision made without fully understanding why someone else had already walked away. And with that realization said, the war moved into its closing chapters, carrying forward lessons that would only be acknowledged after silence replaced engines. By the final years of the war, the consequences of the decision had settled into the fabric of Japan's aviation effort. They were no longer debated, they were managed. The aircraft remained in service because removing it would have created a vacuum that could not be filled. Production lines, once opened, could not be easily repurposing. Training pipelines were already shaped around its systems. Maintenance doctrine had been rewritten to accommodate its weaknesses. Strategy, reluctantly, adapted itself to the machine. This adaptation came at a cost that grew heavier with time. Aircraft availability declined to reluctant. Units that once planned missions around capability now planned around scarcity. Operational commanders learned to ration sorties, not because targets were fewer, but aircrafts could not endure sustained use. Engines were run ratted, rebuilt, and reused beyond intended limits. Aircrafts repaired and repaired again, accumulating invisible fatigue with each flight. The cost was measured first in time. Hours spent maintaining one aircraft were hours spent not spent maintaining others. Skilled mechanics were pulled from broader fleet responsibilities to keep a shrinking number of aircraft operational. Spare parts became currency, traded, salvaged, hoarded. Efficiency declined across the entire aviation system, not just within one program. Then the cost was measured in opportunity. Every resource devoted to sustaining the aircraft was a resource unavailable for alternative solutions. Development of replacement design slowed. Incremental improvements absorbed attention that might have been better spent on fundamental change.
Leadership, bound by prior commitment, struggled to shift focus without acknowledging error. That acknowledgement never came. Instead, the aircraft's limitations were normalized. Losses were explained as the price of war. Mechanical failures were attributed to conditions rather than design. Pilots were praised for flying demanding machines under extreme circumstances and honored.
When the fighting ended and the airfields fell quiet, the aircraft's story did not end with wreckage or inventories alone. It continued in reports, recollections, and reassessments, written without urgency, without pressure, and without the need to justify decisions already made. Only then did clarity fully arrive. Post-war analysis stripped the aircraft of symbolism and examined it as it had always been, a machine shaped by assumptions. The most important of those assumptions was that American rejection signaled unrealized potential rather than informed restraint. Once that assumption was removed, the rest of the story aligned with uncomfortable precision. The aircraft had never been unsalvageable. It had been unsustainable. American evaluators had not failed to see its promise. They had seen its cost. They understood that modern air war demanded not brilliance in isolation, but resilience at scale. An aircraft that required exceptional handling, perfect maintenance, and ideal conditions could not be the backbone of a long conflict. Japan had accepted the design believing it could impose those ideal conditions through discipline and planning. War made that impossible. This distinction became central in post-war lessons. Japanese aviation planners recognized that adaptation without doctrinal alignment is dangerous. Technology cannot be separated from the system that supports it. Engines, airframes, crews, maintenance, logistics, and industry form a single organism. Strength in one area cannot compensate indefinitely for weakness in another. The aircraft's failure was not sudden because the system around it was already fragile. In hindsight, the signs were present from the beginning. Narrow margins, high maintenance demands, sensitivity to production variability. These were not flaws to be refined away. They were warnings that the design was mismatched to Japan's industrial reality. American aviation doctrine had internalized this logic early. The United States rejected designs not only for failing tests, but for failing futures. If an aircraft could not survive degraded conditions, inexperienced crews, and mass deployment, it did not belong in long-term planning. Rejection was a form of investment discipline. Japan had interpreted that discipline as hesitation. The consequences extended beyond a single program. Resources tied to sustaining the aircraft delayed alternative paths. Time spent compensating for fragility postponed exploration of designs better aligned with domestic capability. Pride and momentum reinforced decisions that should have been revisited when evidence accumulated. This pattern was not unique to aviation. It echoed across multiple wartime programs where ambition outpaced support. But in aviation, the cost was immediate and visible, measured in aircraft grounded, missions altered, and crews lost. For pilots, the lesson was deeply personal. They had been trained to master machines, not to manage uncertainty built into them. Many carried forward an enduring skepticism of aircraft that promised exceptional capability without proportional forgiveness. In post-war years, this skepticism influenced training culture and operational preference. Reliability became prized above novelty. Engineers, too, absorbed the lesson. Post-war Japanese aviation emphasized incremental improvement, conservative margins, and alignment between design ambition and industrial capacity. The memory of a machine that demanded more than could be given lingered quietly beneath those priorities. In this sense, the aircraft did teach something. It taught that rejection can be a form of wisdom, that restraint, when grounded in experience, is not weakness, that the decision to walk away from a promising idea can preserve strength for more appropriate solutions. The irony was unavoidable. Japan's greatest aviation mistake was not choosing the wrong aircraft. It was choosing the wrong interpretation. America had looked at the same design and seen risk exceeding reward. Japan had seen opportunity exceeding caution. Both were rational within their contexts, but only one context aligned with the realities of sustained industrial war. By the time this became clear, the cost had already been paid. What remained were lessons recorded in quiet language, free of urgency. They did not condemn individuals. They did not dramatize failure. They described alignment, or the lack of it, between machines and the wars they are asked to fight. As history moved forward, the aircraft faded from memory, replaced by more successful designs and more durable doctrines. It did not become a legend. It did not inspire nostalgia. Instead, it became a footnote with weight, a reminder that in war, not every bold choice is brave, and not every rejection is loss. Some decisions reveal their wisdom only when the noise ends, and in that silence, the true shape of the mistake finally becomes clear, preparing the ground for a reflection that reaches beyond one aircraft, into how nations choose what they build, what they trust, and what rejection truly means. When the war ended, the aircraft did not vanish into myth or legend. It did not earn reverence or inspire nostalgia. It simply stopped flying, its purpose exhausted,
its limits finally undeniable, and in that quiet disappearance lay its most important meaning. The story of Japan's greatest aviation mistake is not about incompetence, nor about imitation. It is about interpretation. Two nations looked at the same design and reached opposite conclusions. One walked away, the other leaned in. Both decisions were made by capable engineers and experienced planners. Only one aligned with the realities of sustained war. America's rejection was not rooted in fear of failure. It was rooted in anticipation of strain. The United States understood that modern warfare is not decided by how an aircraft performs at its best, but by how it survives when conditions deteriorate, when crews are tired, when parts are imperfect, when operations stretch longer than planned. Designs that demanded perfection would fail not because they were poorly conceived, but because war does not reward fragility. Japan believed discipline could replace margin. That belief was not foolish. It had worked before in narrower contexts. But aviation at scale is unforgiving. Physics does not bend to determination. Engines do not respond to belief. Structures do not forgive repeated stress simply because necessity demands endurance. The aircraft became a lesson written in metal. It revealed that adaptation without alignment is dangerous, that borrowing technology without inheriting the doctrine that shaped its rejection invites miscalculation, and that pride, once invested in a decision, can delay correction long past the point where change is possible. This lesson reaches beyond Japan. It reaches beyond aviation. In war and in history, progress is not linear. Not every discarded idea is a missed opportunity. Some are warnings. Some are boundaries discovered early enough to avoid greater cost later. The wisdom lies not in always advancing, but in knowing when to stop. Japan did not fail because it lacked talent or courage. It failed because it mistook restraint for weakness. It believed rejection meant incompletion rather than incompatibility. By the time experience corrected that belief, the price had already been paid. The aircraft story ends without drama because mistakes rarely announce themselves clearly. They accumulate quietly, disguised as persistence, explained as necessity, defended as commitment. Only afterward do they reveal their true shape. What remains is not a tale of humiliation, but of insight earned too late. The greatest aviation mistake was not building the aircraft. It was believing that someone else's caution meant opportunity. History does not punish ambition. It punishes misread reality. And in that distinction, between what can fly and what can endure, lies the quiet truth this aircraft left behind when the engines finally fell silent.